Hello, this presentation concerns a new TCPIP implementation for MCP systems. It's referred to as TCPIP v3 or sometimes as networking v3. This is just a general overview of the presentation. Starts with an overview of TCPIP v3, then talks about the management, and its management is hopefully simplified. It talks about using BANA over TCPIP, which improves performance, and it talks about configuring v3 networking both at the system editor point of view and then on the MCP side. And there's a new program that can help with configuring things on the MCP side. And then talk some about the performance. With TCPIP v3, network ports are represented as NP units. They show up as NP units and way similar to packs show up as PK units and tapes show up as MT units. The data path between TCPIP support and all the way out to the NIC is very much simplified and optimized. And also the TCPIP checksum calculations for both incoming and outgoing data, the IP checksum calculations, and segmentation of outgoing data into packets and aggregation of incoming data segments into larger chunks of data on input. All those functions are offloaded to the IOP, and when the NIC in use supports offload of these features to the NIC, the IOP then offloads them to the NIC. Because NIC ports are now represented as IO units, the unit-based mechanisms from the ODT can be used to interrogate and manipulate them. For example, you can say OL NP 300, or you can use the SC command to see all your NP units, and you can do things like freeing an NP unit or acquiring it. Because NIC ports are now IO units, all the unit-based performance interfaces built into the MCP now report data for networking units. So tools that show disk and tape performance by unit can also show NP performance by unit. So you can see things like how many kilobytes per second are going through a given NP unit. And the management of networking is substantially simplified. There's much less complexity. We'll get to it later, but there are no more connection groups or connections, so that makes things simpler. And you can also still use all the old interfaces to query about networking. The old interfaces still work, but the unit-based ones can be more convenient. The code to support TCPIP v3 is built into the IOP algorithms in the MCP firmware. There's no longer a separate set of algorithms that need to be loaded, so NXNet is not used by TCPIP v3. So unless you're using native BNA links, it's best not to even install NXNet. Starting in this release, the MCP environment code files for networking are part of the general MCP environment package. So you don't have to load a separate set of code files in the MCP environment. And that's true whether or not you're using TCPIP v3. And also the same TCPIP support 2 code file is used for both TCPIP v3 and traditional TCPIP. So when the TCPIP v3 algorithms and drivers are loaded in the I/O environment, TCPIP support 2 detects that and automatically runs in TCPIP v3 mode. Otherwise, it runs in the old traditional mode. Now, there's been 2 flavors of BNA. The first is the original flavor of BNA, often referred to as native BNA, and that uses proprietary packets. And then there's BNA over IP, or BIP, and that uses IP packets. In both these cases, the data goes basically from the BNA library in the MCP all the way out to the network and then into the receiving system and through the network stack up to BNA support, one LAN segment at a time. So that really limits the performance. With networking v3, if both systems in a neighbor pair use TCPIP v3, then BIP negotiates the use of TCPIP rather than using IP packets without TCP. And we refer to this as BNA over TCPIP or bot. And it's negotiated during the BIP greeting exchange. And if either neighbor is not running v3 networking, then BIP is used in its traditional mode. So that gives straightforward migration. All you have to do is install v3 networking at both ends, and then bot will automatically be negotiated. Compared to BIP, bot is much faster. When streaming data will go in large chunks between the two BNA libraries. It gets sent out in chunks up to 65K, and basically all the way out to the NIC card, it stays a chunk of 64K, and then gets broken up into LAN segments. And at the receiving end, the NIC card will put segments together, and then the IOP will combine those chunks, and so the chunks of data coming in will be very large also. And so that makes BIP much faster, bot much faster than BIP. And also it's much more resilient to LAN congestion than either BIP or native BNA, because with BIP or native BNA, the retry of lost segments is done up at the BNA layer, and that's much less efficient than the retry of lost segments done by TCPIP. So if there's any network congestion, bot will handle that much better than either the old versions of BNA. And then compared to native BNA, bot is also significantly faster in nearly every instance. Again, that's because native BNA is sending individual LAN segments all the way up and down the networking stack, and bot is sending much bigger chunks of data through the networking stack. Okay, now I'll talk about setting up and configuring networking v3. Within System Editor, each NIC port appears as a CHAN and NP unit pair. So there's one entry in the system editor for each NP unit, and the CHAN NP unit thing is simply because that's the way everything's designed. Every unit has to have a CHAN. And for EVLAN ports, SBAR ports, and Team and VLAN ports that have been created, these will be presented to the system editor as virtual units. Ports on physical NICs will be presented to the system editor as PCI units with PCI addresses. And on platforms where the BIOS reports slot numbers to Windows, the physical NICs will also show the slot and port number. And the next line is sort of an example. For Libra 4300, 6300, 8300 systems, the BIOS does report slot and port. And so the system editor is able to produce fairly nice default device numbers. As you can see, they're based on the slot and port number. So for example, if you have a 4-port NIC in slot 1 on ISM 1, the device numbers would be 305, 306, 307, and 308. Now, one needs CNS and TCPIP configuration files to use MCP v3 networking, and you can use the traditional methods to make those, but we've also written a program which we hope will make it easier and more intuitive to set up a configuration for a straightforward configuration. It's called System Configure TCPIP, and it's a wizard type program. It runs from an MT terminal, and it shows you walks you through a sequence of screens where one can answer questions or enter data, and that way one can establish an initial configuration, and then if one runs the program again, it presents the data in the current configuration and one can update it. It must be run from privileged user code, and our documentation suggests running it from Mark because that's probably the easiest thing for a new user to do. It could also be run from Candy. For BNA, existing BIP config files should work without any changes, provided that the IP addresses haven't changed. If the IP addresses have changed, then one would have to edit the IP addresses. But when migrating from old style network to MCP v3 networking, the BNA should be very straightforward, as long as one is on BIP. For TCPIP v3 NP units, there is no connection group in the CNS config file, and there's no connection in the TCPIP config file. There's just an identity entry in the TCPIP config file, and that's all you need. And for TCPIP v3 NP units, the networking software generates a connection name and a connection group name that has actually the unit number of the NP unit in it. And those names can be used for program agent queries. So most program agent queries will work even within TCPIP v3. Program agent modifications don't work, so you can't manage TCPIP v3 units using connection or connection group mechanisms. And then the MT from the that's configured in the NIC is what is used as the MT. The MTU configured in the NIC is what is used in the by TCPIP support. It just queries the NIC and uses that value, so there's no longer in traditional networking, there are MTU values in the connection entry in the config file and in the connection group entries in the config file. That's all gone. The system just uses the MTU that the NIC's configured for. Okay, for system starting types that start shipping in this year, 2017, the Windows drivers used by V3 networking are already installed, and no update to these drivers or to the MCP firmware is needed when upgrading from 17.0 to 18.0. For existing system types, we plan to allow TCPIP v3 to be used on the Libre 4300, 6300, and 8300 systems, and that will require an MCP firmware service pack, at least service pack 1, and then installation of a separate package with the v3 Windows drivers. And installation of that package is what triggers the switch from traditional TCPIP to TCPIP v3. Once those drivers are present, System Editor will see NP units, and once NP units are presented to TCPIP support, he will run in TCPIP support v3 mode. Other system types are not upgradable to v3 networking at this point. Okay, we'll talk a little about performance. Compared to traditional TCPIP, performance is greatly improved, and also CPM overhead is greatly reduced. On traditional TCPIP, jumbo frames made a significant difference in performance. That's not true with v3 networking. With v3 networking, segmentation on output and segmentation aggregation on input are offloaded to the IOP and the NIC. And because of that, the size of chunks of data going through the whole stack from the IOP, between the IOP and TCPIP support, tends to be much larger than segment size when larger amounts of data are being sent or received. And that means there's very little advantage to use of jumbo frames. The only advantage of using jumbo frames with v3 networking is that there are less headers on the wires, so you get a very, very small increase in wire utilization when you go to jumbo frames, but that's really the only advantage. It's a very small amount. So we've done some testing of latency, and when using high-speed servers and high-speed CPMs, we've seen round-trip latency of about 220 microseconds. And that's for a 1,000-byte message going from an MCP program out to a Windows system, being turned around by the Windows system and sent back to the MCP system, and then read by the MCP program. So that entire round trip is 220 microseconds. And over half of that latency is in the MCP CPM environment. Use of lower speed CPMs will increase latency, and use of virtualization technology will increase latency. Okay, we've done some testing just with test programs for throughput, and with 1 gigabit network hardware, it's usually possible to achieve wire speed. With 10 gigabit network hardware, you can often achieve very close to wire speed. But use of slower speed CPMs or use of virtualization technology can impact the ability to reach 10 gigabit network hardware speed. In order to maximize network performance, it's fairly important to configure the network drivers the NIC drivers correctly, and that basically means having them in default settings. The two things that are really important is that the NIC should be configured for adaptive interrupt moderation. That is the default, and we found that any other setting we've tried really causes problems either for streaming data or for latency or both. So really strongly recommend that you just leave the interrupt moderation enabled and set to adaptive. And also all offload capabilities should be enabled. That allows the IOP to offload functionality to the NIC for things like checksum and segment aggregation and segmentation on output. So if you leave the NIC in default settings, you'll have all these things, and that's really what we strongly recommend. Just leave the NIC in its manufacturer default settings. Another thing that's sort of not obvious is that Netmon and Wireshark seem to cause problems. We have seen them hurt performance when doing testing at 10 gigabit speeds, and this is true even when they're installed but not active. So it appears that just having the Netmon or Wireshark driver in the Windows networking stack causes performance issues. And on looking into this, we found that basically inbound packets sometimes get dropped. It doesn't always happen, but sometimes there'll be fairly heavy interference with inbound packets by having these drivers installed. So our recommendation is, if you need Netmon or Wireshark for debugging, install it, perform the debugging, and then uninstall it. Okay, performance of file transfer. Okay, now we'll talk about performance of a real task. The previous performance slides talked about artificial benchmarks. If you use NFT over bot or FTP and you're using TCPIP v3, the throughput will be very similar. With 10 gigabit network hardware, you usually can achieve wire speed. So with 1 gigabit network hardware, you can usually achieve wire speed. With 10 gigabit network hardware, all the tests we've run show the speed limited by the disk units rather than the network. Okay, if you want to monitor the performance, you can use the unit-based performance tools and look at the data flowing through any given NP unit. System Observer is useful in this regard. You can specify kilobytes per second in the unit display and specify all for unit types, and then you'll see the how much data is going through each individual NP unit. This is the document that describes TCPIP v3, and the information here is quite useful, and it's what you should refer to when you set up TCPIP v3 or operate it. Okay, thank you for listening.
We hope you found this presentation useful and informative. Unisys offers a comprehensive set of ClearPath Forward services to enrich the value of your ClearPath Forward applications, data, and systems. Please contact your Unisys representative for more information. Thank you for your continued use and support of Unisys ClearPath Forward systems. Good day.